Dear students, today we will see the methods for handling deadlocks. We know that there are four causes or reasons for deadlock. One is mutual exclusion, second one is hold and wait, third one is no preemption, and fourth one is circular wait. Where we know that first three, that is mutual exclusion, hold and wait, no preemption, are indirect causes of deadlock, whereas circular wait is a direct cause of deadlock. Okay, so let us see how to handle the deadlocks if they occur. So there are four ways to do it. One is deadlock prevention, second one is deadlock avoidance, third one is deadlock detection, and fourth one is recovery from deadlock. Now coming to deadlock prevention. What is deadlock prevention? So to make sure that out of these four causes, which are those four causes? One is mutual exclusion, hold and wait, no preemption, and circular wait. Can we have a technique which will prevent these to happen? Okay, so if we can make sure that any of these four causes are somehow handled so that they will not happen, then we can prevent a system from getting into a state called as deadlock. I repeat, any of these four causes of deadlocks, that is mutual exclusion, hold and wait, no preemption, and circular wait. If somehow we are in a position to make sure that these four things doesn't happen, then we can prevent a system state called as deadlock. This is what we call as deadlock prevention. There are many methods. We will see in detail whenever they comes in due course of time. Now next one is deadlock avoidance. Now in this case we need to, as name suggests, we need to avoid the deadlock. As it is, we try to avoid accidents on road when we are moving through a car. Okay, what we do, we should make sure that our speed should be below 80. We should be concentrating on road. Okay, so all these things or precautions will help me to avoid the accidents. Usually accidents happens when we are moving too fast on a road. So here we know that in deadlock avoidance we have all the data, that is how many resources are there, how many processes are there, and when they require. So if it is cases, then when we have all inputs, we can manage them or keep them in such a way that there is no a system state called as deadlock state. Okay, so deadlock avoidance is possible only when we have all inputs, number of processes and number of resources. I hope it is clear. We will see it in detail later. Now next one is deadlock detection. Now somehow we found that working of my system has, that is working or progress of my system has stopped, or progress is not as expected by the user. Then we have to check two things here. One, whether the progress has stopped because of the deadlock or some other reasons. I repeat, progress of my system has stopped because of deadlock or any other reason. There might be other reasons for which the system might not be progressing as we are expecting. So that is what we do it in third method, which is called as deadlock detection, wherein we try to know if my progress of the system has been halted or stopped. Then we find out that is it due to deadlock or some other reason. So once we detect, yes, there is a deadlock in the system due to which progress of the work has been stopped, then the third work is done, which is called as deadlock detection. And last one is recovery from deadlock. One, a deadlock detection has been done, then we have to choose some measures so that the deadlock can be recovered from the deadlock state, and the progress of the system can be moved in a better way or a faster way. Hope all four handling methods are clear. Deadlock prevention, where we try to prevent the happening of the deadlock avoidance. We will try to avoid the happening of the deadlock. If my progress of the system is not so or expected as expected, then we check whether that progress has stopped or halted because of deadlock or some other reason. If some other reasons are there, then we will go ahead with the solution. If it is due to deadlock, then we have to find some ways to get the system out of that deadlock position. If deadlock is detected, the fourth step is, or method is, we have to recover all the inputs or the system from the deadlock state and move it in a better way. Now there are three states which we have to discuss here. One is safe and unsafe and deadlock state. See here, we will understand these three terminologies with the help of this diagram. Here we can see a safe state. There is no question now deadlock happening. What is safe state? In safe state there is no question of deadlock happening. Okay, and unsafe state. In unsafe state there may or may not be chance of deadlock. I repeat, in unsafe state there may or may not be the happening of the deadlock. Okay, and usually deadlock happens in unsafe state. We know what is deadlock. Okay, usually deadlock happens in the unsafe state. That means in safe state there is no deadlock, there is no occurrence of deadlock, there is no chance of happening deadlock, and all systems which are in unsafe mode may or may not find a deadlock. I repeat, may or may not, but all deadlock state systems are in unsafe state. I repeat, unsafe state there may or may not deadlock happen, but if you find a deadlock, then that deadlock always happens in unsafe state, not in the other state. Okay, I hope it is clear what is safe state, what is unsafe state, and what is deadlock state. I hope you understood the concept and different methods to handle deadlocks. Thank you very much for watching.